Hello and welcome to the Side One YouTube channel. My name is Ray, and in this video, part 3 of an R2D2 build, we're going to look at the left-hand wheel drive assembly. So I'm building the Mark III version of Mr. Baddeley's design of R2D2. There is a link to where you can get all the files from his Patreon in the description, but I want to compare the drives of the version 2 and the Mark III. So I have here the wheel and belt from the version 2, and this is the pulley that was on the motor and that drives through. And one of the issues I had with this one was the motor was not powerful enough. Now the motor I'm using is one of these scooter motors, MY6812. It's a 12 volt 100 watt motor. When it comes, mine arrived with a sprocket to drive a chain, which I've since removed for the to drive the robot wheels. One of the changes between the Mark II and the Mark III is when you look at this, your gear ratio is the size of this pulley to this pulley, and it wasn't a very big ratio difference. In his later design, he's come up with these 3 sprockets, and that gives us a larger gear ratio. So the motor has to turn more to get the same distance travelled. That increases the torque at the wheel and reduces the torque required from the motor. So hopefully this will overcome the issues. What I've read so far suggests that it does. If you compare this pulley with this gear, they're about the same size. If you compare this pulley and this gear, which is the one attached to the wheel, again they're about the same size. So the difference is in these 2 sprockets, which gives us the bigger gear ratio. So let's get into the assembly. One of the other major changes that was made is this component has been split into 2 parts. I've printed this in ASA, and the reason it was split into 2 parts was to make it easier to get this tyre on. Now this tyre is printed in TPU. All the red components I've printed in ASA, and this piece, which covers our gear, was also printed in ASA. So let's just start assembling. We'll start with the tyre. So TPU print came out not too bad, a little bit rough over here, but other than that, not too bad. This goes on, and then we use 3 self-tapping screws to hold it in all together. Okay, so there's keying on the sprocket. It lines up with these holes here and holes through for screws and nuts, so that drive assembly is held fixed. For that, we're going to use M4 nuts, and this is an M4 by 25mm screw. Feeds in from this side, and then we just do it up. Okay, so that's the first part. Now, each side of this carries a bearing. It's a 608. I'm using 608ZZ. That means they've got steel shields. 2RS have got rubber shields. You can use either one. I happen to have 2 ZZs on hand. Okay, so I'm just going to put that aside for the moment and bring out this gear. So this gear uses slightly smaller bearings. These ones are 606, I think. and I can't get that to focus. 606ZZ, so these are also, like, they're smaller than the 608s. One goes on each side. Again, I'm using steel shields because that's what I've got, but you can use 2RS, which are rubber shields. Okay, now from there we need to start looking seriously at part of the framework. So this is the Mark III drive assembly pod. So the top's up here, the bottom here. Our motor fits into here, and you can see it has a hole made for this wire to poke through from the motor. But we're going to put this wheel or pulley in. But before we put the pulley in, we need to put some square nuts in there, and I might even weld those into place so I don't have an issue with them. Now what pokes up through there is this piece. Again, I printed this one in ASA, and it pokes in from the other side, and then 12mm screws, I think they are. Yes, they are. Flathead or countersunk. Now I'm just going to temporarily screw this in while I weld the nuts into place. I don't want these nuts coming loose. I am requiring a complete disassembly. So this is up to 235 degrees C. This grey piece was printed in PETG, so I'm using PETG, in this case white, to hold this screw in. Or I should say, hold this nut in. Now there is a new version of this part, a modified version, that actually has a hole down through the middle for a small screw to give it a bit more strength. I haven't printed that one out, and it'll be some time before I get around to printing it out. So I'm just going to put this in as is, and if I run into problems down the track, I'll just have to pull it apart. Now don't over tighten this. With the ASA I've already cracked this part, and it's not easy to repair. You can use acetone to weld these bits together with the ASA, but yeah, I'll leave it as is for now. Alright, so this part supports the other end of the shaft and holds everything down. But there are two square nuts. One in through here and one up through the bottom, and then our screws come down and lock it into place. Alright, let's get our motor ready. So I've put ferrules on the ends of these wires. These are 1.5mm square wires and just a 2-screw tunnel connector, just to keep it all neat and tidy. But we do need to fit the gear on. So the gear will go on like so. But before we put that on, we'd better put our square nut in. So we have our square nut. This is again M4, and this is an M4 by 12mm screw. I found that the 10mm screws are just a little bit too short in the countersunk format, and the 12s are a little bit too long. And this one seems 12mm pan head, I suppose you call it, is just the right size. So we'll fit that on. And do our screw up. And I think I cracked all of that, so I may be reprinting that in PETG down the track. Drop that in. And try and line up our sprocket. You can feel the cogging from the motor, so I think that's aligned pretty well. Now I do need screws for that. So M4 Hex nuts, which go into these hex holes. And the screws, again a pan head, and these are 16mm long. Now I'm going to lock these two square nuts into place. Now before I get too carried away with the rest of the assembly, there's 3 more of these square nuts to go in on this framework, plus one over here and one over here, which will be needed later for the body. So I might as well get those in while I'm at it. Now I'm putting the screws in to hold them so they don't move while I'm moving this around or gluing it in, welding it into place. And I can pull these out later when I need to, like when I'm putting this top cover on. Okay, so I had a bit of a problem with my microphone, so let's pick up where we left off before. We have an axle, so that's this component, which sits in like so, has a square nut, fits in here and gets attached to the back via a screw. So that then supports this wheel on here, connected to the gear assembly, and that should work quite well. But before I get into that, what I should probably do is clean up some of this and actually assemble the Omni wheel. So the Omni wheel has 2 parts. They don't go together. They do. Each of the wheel assemblies, and there's 2 of them, has a 608 bearing in the middle, and we have these rollers. Now if you watch part 1 of my series, you'll see that this is a TPU printed tyre, and inserted in the middle is a former which goes through. I had to use a vise to get that in. I doubt I'll get it back out. And then I put in a small bearing here, and I do have a listing for that bearing, and that would be a 683ZZ. So there's a total of 16 of those used, and then we have these brass rods. These brass rods are 3mm in diameter to go through that small bearing, cut to 40mm long each. I put in, I I think it was 2 lengths of this for this assembly. And they just sit on like so. So there's little notches in each of these for the brass rods to fit into, and that's what holds them in place so they don't fly out. Actually, if I was smart, I'd do it on this end. Now the reason why we have the Omni wheel is the main wheel, drive wheel, sits on one side, and so the other side would become unstable. And this helps stabilize it a bit. So we're going to sit that like so. We're going to use these 12mm long countersunk M4 screws. We drop one in there, and if we carefully pick it up, on the other side we have provision for a hex nut. And that fits into its little hole, and then we do up the screw. Now I suggest doing the diagonally opposite one next. And that should help hold all of your rollers in place. Otherwise they have a bad habit of trying to escape. Now, make sure you've got one flat and one that either has raised pins or grooves or holes for those pins to fit into. And then on the other side we have a flat and the one with the pins to fit into. So we're just going to repeat that. Okay, so these holes and pins line up, and there is only one correct way to put them in. They will fit in and line up, but these wheels will be touching, so that's the wrong way. When you get them where they're 45 degrees out of line with each other, that's the correct method, and that allows these to roll and move in any direction. Alright, so now that I've got them out of the way, I think the next thing we need to seriously consider is mounting the mounts for that bearing assembly. So these mount on the base and the side cover. Sorry, that goes that way. And the idea is to try and get this wheel, and I dropped that bearing out, as close to center of our Omni wheels as we can. So I'm thinking from memory it was this one. Goes here. And then the other one goes like so. So these are held in with hex nuts. I dropped one. So we drop a hex nut down the bottom of the hole. And I've already got the hex nuts in those holes. So let's screw this one in. And this uses 25mm long screws. 20 will do the job, so I might go 20 instead. So while I've got this in this condition, I might just put our square nut in here, slide it in our hole. You can, by the way, put bolts in here instead. There is provision for the bolt head to sit into the hole here, and your nut will go into that slot there, but you need to know where you're putting it. So on the back of this, we put our washer, and we get a 25mm screw. No, maybe a 20mm screw. That's better. And we'll take this one. Again, this is for the Omni wheel. We put our square nut in, put it in the hole, and that's our 25mm one. But I need my washer. So these are designed for the counterhead screw to go in there and lock it up. Okay, so that's that. Our Omni wheels can now drop onto there, and we can put a little square nut arrangement on there. This one, and I can feel that cogging, so that's in the right position. Alright, so before we get too carried away with trying to put side plate on, actually I might just put this piece in. This is the other half of that one, goes on that way, so mounts on like so. Has a hex nut go on the back, and a 12mm screw, M4 screw, fits into there nicely. Alright, just going to put that aside for the moment. Now, this pin is actually printed as two parts, and because I printed this in ASA, I could use acetone to actually glue it together. Just paint a bit of acetone on each side, push them together, hold them together until the acetone dries out, and you've got a simple pin that will go through that hole. We'll need that a bit later. For the top frame, this is where our ankle is connected. So what we're going to do, these are the other two pieces associated with the ankle. That goes up that way, so that the wheel has that little cutout part on it. That will go there, and this one will go up here. And maybe it goes the other way. That looks more like it. It puts the pivot right in the center of the wheel line. Alright, so before we can put all that together, we have two square nuts need to drop into these holes here. So I'll do this one first. We then grab a 25mm long screw. That will poke in through that hole. Drop a square nut in here and do that screw up. Just do it loose for the moment. Oops, my nut fell out. Now these other two screws on this piece are 12mm screws, countersunk. And then repeat for the other side. I've put them on back to front. Now I did print all of this in ASA, which means I'm probably not going to be able to use PETG in the 3D pen to hold these in place. And what you're looking for is they should be finishing flush. And if you get it the wrong way round, like I did a second ago, then it won't finish flush. Okay, so that's that assembly. Now this assembly fits so that your curved part here lines up with your wheel, and you'll see all of these holes down the edge, they line up with these little teeth, the herringbone, and it just pushes in. We can now put a couple of screws in to hold it. So I'll just drop my wheels. Well, a screw from this side anyway. So that'll be a 25mm screw, and that'll stop it from sliding out. We will also put some screws in here and here, but they have hex nuts going on the inside, so we'll need to make sure they're in first. Before I get too carried away with putting all that back on there again, we do have these spacer blocks here to go in. Now this funny shaped one goes in here. What makes this one a little more difficult than the others is you can't put it in later like you can these two, and it does have square nuts go into it. I printed these in ASA. In hindsight, I should have used PETG, and then I could glue the nuts or weld the nuts in so they don't come out loose. So let's get this in. And again, it's a 25mm screw, sorry, 20mm screw, countersunk, M4. Alright, so we need to put this one in here, again, M4. We can do that after, because we can slide it up from the bottom. Same with this one. This one goes in near the Omni wheels, and it has a little cutout in it. Only goes in one way, like so. So let's put these Omni wheels back in. Drop those on. The direction they go on doesn't really matter a great deal, just as long as they're on. Make sure this cable's hanging down the bottom, and then we can slip the top over. Now I have previously welded in 2 square nuts in through here. You can just see the nut in there, and over here as well. And they're actually used to mount the top cover on. When I say top cover, the how can I describe the shell, the skin. And that nut's not going in. adapter. Alright, so we have a heap of screws to put in now. Hopefully that nut's still there, so let's get him in first. That's into that ASA piece. And get them done up. They're all 20mm long. Okay, we're getting there. Now to keep this cable so it doesn't drag down and get caught under the wheel, in the version 2 wheel assembly there was a piece that fitted in here and you put a couple of screws down to hold it. In this one it didn't have that in the parts list, so I'm just using a cable tie. This is a small cable tie. And that just stops it from dropping down and getting caught up anywhere or being snagged on something on the ground. Now we can put these two pieces in. So, square nuts. Pushes up from the bottom. And then we can put in the screws. 20mm M4 countersunk. And do the other side before you lose your nut. And my nut has come out. Try that again. And that leaves me with this one. So this curved profile faces towards the Omni wheels. Again, another 20mm screw. And again on the other side. Okay, so the last 4 screws are in the top. They go through the side panel and there's a hex nut in here. So let's drop our hex nut in our first hole. On the thick side, we're using the 25mm long screws. and I'm relying on gravity to hold that nut down. Then over on this side we've got another one, and you can just see the hole there. Drop our nut in, come up from underneath, looks like the nut has grabbed that. And repeat for the other side. This one's a bit easier. The nut's not as deep. These are 20mm screws, M4 countersunk. Easy done, that one. Okay. Then once the shell's on, we can use this to attach the ankle in through here, or you could put a nut on the back here. It needs to be a shallow nut, M12, and put an M12 cap head screw through. One suggestion I've seen is you get a long one, about 120mm long or 110mm long. That way you get a flat spot here or a raised part, and then cut your bolt short to suit. So only thing I've got left to do with this is just test to make sure the motor spins. So I'll just grab my battery. So this is a 12-volt battery. It's only a small one, 5 amp hour. Okay. So on the wires coming out of the motor, these are coloured brown and blue. Brown is your positive wire normally, blue is your negative, that's European standard. I've got a red and black wire here. This wire is long enough to go up through my R2D2's leg. And I'll just use a screwdriver to do this up. So I'll use the Australian standard here. Used to be red and black, red for positive and black for negative. I think America uses white for the negative and any other colour as the positive. But let's see if this works. Make sure my wires are out of the way. And that looks good. Alright, so in the next video, I'll assemble a skin. My printer's not big enough to print the pieces in one piece, so I've had to do a split, so I'll be welding those splits up. And we'll put the skin on top of this and screw it on. We may even get to the battery box. To see when that video is released, don't forget to click on like, subscribe, and ring that notification bell. It's also a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account and YouTube membership. You'll find a link in the description. I'd like to thank my VIP patrons Go Lucky and Copernicus, my All Access patron Jeff Jerd, my Builder patrons Al Morales 45, Andrew Cardone, Airgar69, Stefan Paps, James Kelly, Guy Dormery, and my YouTube member Magdi Salib in helping to support the channel. If you've got any questions, feel free to leave a comment below or drop into the Discord and ask there. If I can't help, then someone else in the community might be able to. And we'll see you in the next video.